Welcome back to Further Solutions Academy. Further Solutions Academy. Further Solutions Academy. Encourage young people. Help us to share and subscribe. Help us to share and subscribe to this channel. If you have not subscribed before, just press on the subscribe button just to get alert on what is going on this channel. In this channel, we have over 160 videos with different topics. It means you can come here and learn and write any exam and pass without any stress. That is what is there. Now, in this video, I'll be walking you through Perseval formula. Now, it's a very powerful formula under Fourier series that we need to understand. Now, when we talk about this formula, it's just like simple way of handling Fourier series, which is being different from others, what we have been doing. Now, just note that the Perseval formula for the Fourier series, Fourier series f of x over the interval minus c to c is integral run from minus c to c f of x bracket of squared the x will be equals to c bracket of a of n squared all over 2 plus summation run from 1 to infinity, and I have a n squared plus summation run from n to 1 to infinity, which is bn squared. I'll close my bracket. Now, that is what Perseval is saying. That is what Perseval is saying. This one is being different from normal Fourier series. It's being different from normal Fourier series. And when we're talking about Fourier series, I think we have done, from our previous video, we have known what our A0 and AN and ABN. Let me recall that. Just recall that. We have to know that. Let me just recall someone that A of n is equals to 1 all over c integral from this to f of x cos n s all over c dx, and also which can also be with this, which is called, this is the Perseval side of it, which I'll be having c of a of n equals to integral from this to this of f cos nx pi all over c. That is that. And similarly, my b of n, we have the same thing, which is my b of n, c of b of n. We all know what our b of n is saying. Okay, before we continue, my b of n is always equals to 1 all over c integral run from minus c to c. Now, function of f of x, which is I'll be having sine Sn n all over c dx, which also will be c p n equals to integral run from c to of sine Sn x dx all over c. Now, and my b of a naught, my a of naught will also be equals to 1 all over c integral of minus c to c f of x dx, which also will be a naught c equals to dx. That is what we are saying. That is how this is being generated. With that, we can now do much. I don't even need to stress much myself. Now, please take note of this information. Now, let me generate a problem that will help us to explain Perseval. I will not be able to watch with me do more things because of time. Now, if I have this type of problem, if 0 less than x less than 2c, show that integral from this to 2 f of x to the x equals to c bracket of a naught all over okay, a naught all over 2 plus summation of n to 1 and a of n cos a to n cos nx all over c plus, I have to put it there, plus summation integral long from to infinity b of n sine n all over c. Now I have this. I want to show it. How will I show it? That is where. Now, how do I go? I'll solution to this. Now, how do I solve it? The first thing is recall f of x equals to a naught all over 2 plus summation run from this to infinity a of n cos n I x all over c plus summation run from infinity bn sine nx pi all over c. Now, please take note of that. It's very, very important. Now, since we know that, we can now say that what? Integrate all, which is integrate all through at interval of, what is that interval? Now, interval of is 0 to 2. Yes, 0 to 2c. That is the integral. Now, how do I go? It means I will integrate this. It means I will. Okay. Oh, before we integrate all through, we have to know that before we integrate all through, there's one step I step out there. It means multiply all by f of x. Now, if I multiply all by f of x, it means I'll be having f of x dot f of x equals to a of naught all over 2 f of x plus summation to infinity to n, which is I'll be having a of n cos nx pi all over 2 f of x plus you have what? B of n sine ns pi all over c f of x. Okay. Now, since I have multiplied all through by what? By that, it means by this, at this point, I can now say that what f of x all squared equals to everything that is there, which is f of s all squared equals to everything that's, I don't need to restrict all what is here. It means I can turn it to what? F of x into squared. Now, since I know that, I can now say that integrate all through at interval of, what is that interval? 0, 2c. Now, since I have it this way, I can now say that what? My integral run from 0 to 2c, which is f of x squared equals to, with respect of x equals to, now I integrate everything that is there. That is just the meaning. I integrate everything that is there. I don't need to stress myself with interval of 0 to 2c. I don't need to stress myself with that statement. It means integrate of 0 to 2c. Okay. Integral of 0 to 2c, and also integral of what? 0 to 2c. Now, since I integrate everything like that, it means all I'm having there is that I'll be having, after I integrate that, I'll be having square of everything, which is okay. Now, since I have it, I will now say that recall that a naught equals to what is my a naught? We have done our a naught, which is 1 over c integral of 0 to c to 2c f of x dx is an integration. Now, f of x dx, since I have it, which I'll be having my a naught equals to integral run from this to c f of x dx. Is there my function? Is there any function? No function. I don't have any function. It means since I don't have any function, I have no problem. If I have a function, the function will just be here and I will integrate it. Now, since I have it that way, I will move on by having my b of a of n also equals to, it will be 1 all over c integral of f of x cos nsi all over 2c. Now, all over 2c. Okay, is it all over 2c? Yes. Okay, all over 2c. Now, okay, all over 2c with respect of the x. It means I'll be having 2c. Okay. Which I'll be having c of a equals to integral of f of x cos nxi all over c dx. Now, I'll continue by b of n. My b of n will be equals to 1 all over c integral of f of x sine Sn pi all over c dx, which also b of c of n equals to sine nx pi all over c dx integral run from, hope you know, 0 to c, 0 to 2c, 0 to 2c. Now, since I have it this way, I can now continue by having, now my Perseval can come to play, which I'll be having my f integral to 2c f of x all squared will be equal with respect of x equals to, now I can now balance everything by having, now I'll be having, what is my a of n? Now my a of n my a of n all over 2 integral of f of x, the x. Okay, which is it will be equals to, okay, this, and also I'll move on to my summation run from this to this, which is I'll be having a of n, which I'll be having integral 0 to 2c. I'll be having 0 to 2c f of x cos nsi all over c. Now also plus summation run from n to 1 to infinity, which I'll be having b of n, and integral run from this to 2c f of x sine nx all over c dx. Now, which is what I'm trying to work on. You can see there that which I will now move on by having, this does not take much time. Okay, which I'll be having there. From there, I can now continue by having, I have b of n, I have b of n. Now it means my integral run from 0 to infinity to c f of x squared the x equals to a naught all over 2 c of a naught plus summation of n to infinity, which is I'm having a naught c of a1 plus summation of n to infinity. I'll be having b of n c of b of n. Okay, now since I've had this, I can now say that which is my integral run from 0 to 2c f of x, the x, it will be equals to, c is very common, I can see that my c into big bracket of a naught squared all over 2 plus, and also I have summation of n to 1 to infinity, which is a n squared plus b n squared, which is, yes, c is already out of the bracket. I think I'll be having that. Since I have that, it means what I need is already has been proved. What I need has been proved. I don't need to stress myself again. Yes, that's what I'm trying to say there. That is proved already. I won't do much here on this video. Even my lab in our class here, there's no light. I think we have to figure out that light issue. Once again, for the Solutions Academy, encourage us more, help us to share our video and also subscribe to it. Thanks so much. Help us to share if you are not, help us, and also subscribe to it if you have not subscribed before. Thank you so much.